Welcome to another Granularity AI tutorial. Today we are going to talk about something that again is more nuanced, kind of similar to our conversation about taste. This one is going to talk about something a bit more less talked about, something called heuristics. And what heuristics are is a mental shortcut to make decisions quicker. Now, in your AI engineering, AI development, you will want to use conservative heuristics for your AI product. Now, I have some of my favorite heuristics. We're going to run through a quick example of a simple heuristic that you can use. I'll throw the code to GitHub as well to kind of do an example of this heuristic. But um, there's three heuristics that I do use often. One of them, I have some notes here, is the where is it? Uncertainty. Uncertainty first. Mm, The uncertainty first heuristic is if inputs are missing from the model. Default to the agent saying instead just simply undeterministic or no answer found versus giving some random concocted answer that could be a hallucination. Um, this, rather than overfitting for false information, or overcompensating for false information. This instead just lets the model say, I don't know. Now, obviously, this isn't always a good thing, right? When the model says, I don't know. But in your agentic process, if one agent can't solve a problem or is undeterministic, maybe it's a signal for another agent to reroute that question or that query, right? If one routing is undeterministic, it then tells the another agent, a routing agent, to reroute it to search or something else or to another database or another MCP, whatever it may be. So that's one. Another is uh a I think it's asymmetric error heuristic. For this one, false alarms can be used as an important gauge. Possible false alarms should be treated as possible disruptions versus no impact. Over optimistic forecasts can be, I'm sorry, not optimistic forecasts can be posing as a blind spot and should be penalized more than pedestalized. For example, um, anomaly detection, right? In anomaly detection, you sometimes don't all you want to pay attention to constant anomalies even though like they happen one time and maybe you don't need necessarily to pay attention to them every time. You still want to jot them down, right? Because they can reflect something underlying that you may not have noticed. So using this asymmetric error approach in your heuristic pays attention to those anomalies. It pays attention to those false alarms and instead say, okay, this false alarm has occurred three times or two times. We should probably begin looking into this as to why this false alarm has occurred three times in a year. What is giving these random false alarms within our logic, and how can we handle them when they do happen so they don't become more and more over time? Now, my favorite is threshold. Where is it? Is threshold and gating. Now, the reason why I do like these is because it adds, so bottlenecks sometimes can be a bad one, right? Sometimes you do not want bottlenecks in your processes or in your logic, but sometimes bottlenecks are important, right? And a threshold kind of adds that bottleneck, sorry, to give you to remove a lot of the clutter and the noise that maybe your model might be experiencing when trying to bubble up an answer to the surface, right? A good example of this is a confidence score. A good example of threshold gating is a confidence score, where unless you, rather than looking at all the answers and all the routings that it's giving you and taking a bunch of time and energy and resources to understand what is the best answer, you instead say, I need the model or an agent itself to vote what is the best answer or what is the best answer from the model that yields the highest confidence score, meaning by confidence score meaning the most accurate answer. Based off of this, you can instead just say, okay, which one are you most sure about, and give me that one instead of kind of reasoning for too long about what you think it could be. You instead get, again, use a heuristic to make quick decisions on what the answer could be. I've used confidence intervals in my own development, and they're extremely helpful, especially when it comes to routing. For example, um, there was a project that I worked on where it was trying to determine whether a user's query needed to be routed to the internal knowledge database, the web search capability, the I think it was web search. I think it was a .gov site or a regulated knowledge base that was outside of our team's internal database. So there was like three or four different routings that could be used to answer a user's query. But the model, the agent had to decide which routing yielded the highest confidence to give the most accurate answer in the end. That's one way of using or confidence levels when it comes to routing. And I think it was accurate 80% of the time. Again, I'm sure with more training and more prompts, and as we fine tuned it, the accuracy could get higher, but 80% accuracy, right, for a kind of an in-house built application is pretty good. We can work on building the prompt and adding more fine tuning over time to get it to probably close to 100% accuracy. We just didn't do that. But that's one example of using a threshold and gating heuristic in your development work. So, in summary, conservative heuristics are decision rules that intentionally bias AI systems towards caution, deferral, and explainability when certainty or potential harm is high. So, heuristics give you the ability to remove a lot of the potential for wrong things to happen. I would say they're kind of like maybe guidelines, or I don't know if anybody's ever been bowling listening to this, but like when you're bowling, right? There's sometimes you want to put up these guardrails to make sure the bowling ball, once you throw it, is still able to hit the pins, right? Usually you do this for new bowlers who've never bowled before. You put up the guardrails so that the ball doesn't go in the gutter and instead stays within the lane so that it can hit the pins. Imagine heuristics are these guardrails, not necessarily for security concerns, but this time for logic concerns. Heuristics are the logic guardrails for your AI development and engineering to kind of keep them in line on making sure, number one, they're deriving the most useful answer. Number two, they're only using resources as needed. And number three, they're not spending an exuberant amount of memory and resources on finding an answer. Instead, you can kind of use heuristics to be more efficient. So hopefully that explained a decent crash course on heuristics, why they're important, and how they can be useful. So I've explained heuristics and what the definition is, uncertainty first heuristics, asymmetric error heuristics, and threshold and gating heuristics. Today, I am going to show you an example of threshold and gating heuristics. So let's minimize this real quick. Excuse me. So I am using also the Databricks web IDE. I've been a fan of it for a while now. I was using Anaconda at first. I was using VS Code at first, Google Colab, and now I'm kind of falling in love with the Databricks IDE. And also, I've kind of just been a Databricks fan since I started out professionally. Like Databricks was the first enterprise IDE I was ever uh, exposed to. So once I found out that they had a community edition, I jumped on. But anyways, if so far what you found in this video is interesting, if it's helping you to kind of think through anything else that you want to apply later to your own AI development, make sure you like, make sure you subscribe, make sure you leave comments. I want to know what you think about heuristics. So now we get to the bread and butter of things. So I'm using Google Gemini for this. Reason being is because I've also become lately a Gemini fan. I think their pro models or their flash models, their pro models are amazing right now. I would argue that they probably are better than Claude and better than the GPT models, in my experience. When anyone asks me what models they should use, I'm usually diverting them now to Google models. But anyways, that's just my take. So here's our AI confidence validator. So we're using 2.0 Flash for this. And the main things that I want you to pay attention to is it here? Parse out regex, da 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 da. So we have four different responses that we're looking for, or at least in one of them, which is the multi sample consensus. You can get four different answers. In the single sample validation, you'll just get um, a general score of like how confident the AI model feels from the answer that was given. But I want us to pay attention to the multi-sample consensus as well as the where's the other one? Okay. Yeah. Answer this query and provide a confidence score from 0 to 1, but or between 0 and 1 for your answer. Query form your responses as answer, confidence score, and reasoning. So this is just a basic confidence determination from the model, right? Asking a question, having the model answer, and then having the model determine how confident it is in that score and why it's so confident. That's easy to understand. But now let's get to the multi one, which is confidence, self confidence, consensus, final confidence, should trust, and I think that's all that pops out. So average self confidence is the average of the confidence scores that the AI explicitly gave to itself after trying the question 3 times um, and seeing what answers are derived. So it takes in the answer or tries the same question or the same response or statement 3 different times to see if it can derive an answer, and then determines, okay, I want to know if it's hallucinating or if this answer is incorrect or if I can even answer this question, right? Consensus score, mathematical score measuring how often the AI gave the exact same answer across 3 attempts. Again, this kind of based off the 3 answers, whether they are identical or different. It then determines, okay, honestly, they weren't identical. They were actually different, or 2 out of the 3 were identical. One was different, or vice versa, where 2 out of the 3 are different, but one is fairly correct or identical. Is the answer reproducible? Is the AI guessing? Uh, that's what you kind of want to know. Is it just guessing? Final confidence score is just again determining using the determinations it's already made whether it feels that the answer or question derived is even or the statement is even useful. Is it useful to have? Is it accurate? Is it the solid truth or is it confidently wrong? And then again, trust this answer, yes or no, blah blah blah. So we are going to run this real quick. Again, installing the Google Gemini. We're going to run this real quick. And these are just our functions. Now we get to the actual run of the logic. And so here we have where it then produces an answer between the question, what is 2 plus 2, and the moon is not real. Or the statement in the answer, or the statement in the question, what is 2 plus 2, and the statement, the moon is not real. And again, it determines like whether this response or this question is even useful. So again, what is 2 plus 2? Answer is 4. It has 100% confidence that this answer is correct. Reason being is because this is a fundamental arithmetic fact. There is no ambiguity or uncertainty. Now, for the next statement that maybe a model might give out, right? Let's say like you ask a question to the model and the model gives let's say like someone asked the question, is the moon real? and the model responds, the moon is not real, right? Now, it shouldn't, it's saying that it has 100% self-confidence in this answer, but after the consensus score, where it tried the model, or it tried it 3 different times, it's giving, yeah, I don't actually trust that this is the right answer. And the final confidence score is that, yeah, we don't trust that this is the right answer after the full consensus of trying it 3 different times and seeing if you got different answers. We can tell this answer to this question, or to whatever question the user had asked about the moon and it not being real, is incorrect. So again, it will say that the trust verdict is do not trust. These are simple heuristics, confidence scores that you can add to make sure and see whether or not the model answers are correct, to see whether or not it's hallucinating, and to see whether or not you're able to use the model efficiently when it's making quick decisions, right? You don't want it to think too hard on what 2 plus 2 is. You just wanted to give a quick answer and understanding that it needs to be addition, that it's a simple arithmetic question, and they can be answered fairly easily. So that's all about heuristics and different heuristics you can use. Please make sure you like, subscribe, find me on Instagram, find me on Substack as well. I think I might include on Substack or LinkedIn. Please make sure you like, please make sure you subscribe, please make sure you comment. Let me know what you think about the video and about heuristics. And with that being said, bye bye.